We just quadrupled our output from the original model by allowing them to have more standard WIP. So next time someone tells you zero inventory is the goal of lean, walk them through this simple example. Now cells can take many shapes, but perhaps the most popular is the U. Now people like it because the incoming and the outgoing are right next to each other, but there are other shapes that worked really well too. I've seen L-shaped cells work well, and I've also seen linear cells work well too. Now there are two shapes to avoid. The first is the bird cage, and last is having the operators located on the outside of your U. Everyone defaults to a U shape when they think of cells. Now I like U shapes, but I try to keep in mind that they may not fit the working environment you're in. The yellow cell you can see is arranged in a straight line. The blue and green production cell was arranged in an L. The shape of the work area made the L favorable. Just keep in mind that you shouldn't feel locked into a particular layout. Carefully consider which shape works best for you and your organization. So there are many shapes that will work, but I'm going to show you a couple shapes that should be avoided. The bird cage looks something like this. There are a couple reasons why this is not a good shape for your cell. First of all, there's a safety risk. In the event of a fire, how are workers supposed to exit the cell? Secondly, the workers completely lose line of sight of each other. In other shapes, they can quickly take a glance over to see the next station to see if they need help in passing the baton. In this model, they can't. Now this is a U-shaped cell, which is fine, but the issue is the operator is on the outside of the cell. I know you won't be able to avoid this all the time because some machines are built to flow in the opposite direction of your cell. But try your best to keep operators on the insides of cells so they can help each other out when they get into a pinch. In this model, operators have to walk all the way around the cell to help each other. I mentioned earlier that you'll have to decide if the cell will be dedicated to one product or if it will be a mixed model system. In this example, we have two dedicated cells. The cell on the left is dedicated to red triangles and the cell on the right is dedicated to blue octagons. One advantage to having dedicated cells is you can have specialized machinery dedicated to that particular product you're producing. You'll also have a shorter training period because workers only need to produce one product. Dedicated cells also allow you to avoid setups, so you may get a higher throughput through this configuration. Your other option is to have a mixed model cell. In both of these cells, red and blue pieces are being produced. An advantage of this is if one worker happens to be absent, you can still get both product types produced. This model is actually more disciplined because it forces you to reduce setup times and think in terms of leveling and cross-training. So long term, this model has an advantage over the dedicated cell model. Again, both types have their merits, so carefully consider how you want to run your cell. I've mentioned several times the benefits of having good capacity linearity. In cells, it's also important. If one operator can produce 5 units, 2 should be able to produce 10, and 3 should be able to produce 15. Actually, as you add workers, the output per worker will increase, but let's assume a linear model for now. So this is a cell with 1 worker. Notice he produces 5 triangles. This is the cell with 2 workers, and they're able to make 10 at the same time. This is the same cell with 3 workers, and they're able to produce 15 in the same amount of time. Now, your model will likely not be perfectly linear, but it's important to have a good understanding of the output based on the number of workers you have in the cell. You can then add and subtract workers in the cell to match changing customer demand. So now that you know how much each worker outputs, you now need to know the theoretical number of workers you need as demand or takt time changes. This is a simple calculation. You take your total work content and divide by the takt time. In this case, your total work content is 75 seconds and our takt time is 30 seconds. This means we need 2.5 workers to meet takt. We rounded up to 3 because we can't have half a worker. So this is what our load chart looks like with 4 workers. And this is what it looks like with 3 workers. Obviously, there's a lot less idle time with 3 workers. When you use this equation, there's a high likelihood that the numbers aren't going to divide evenly. So what do you do with that extra fraction of a person? Here are some rules of thumb. If the fraction is less than 0.3 of a person, then round down. You'll be amazed as to how the remaining workers quickly absorb work and still meet takt time. If the fraction is between 0.3 and 0.5, then round down and try to Kaizen that area for the next 1 or 2 weeks. If they still can't meet takt, then add the person back. As a side note, I've never had to add the person back after this Kaizen period. Now, if you're stuck with a fraction that's 0.5 or greater, then round up. So let's say the equation tells you need 4 people to meet takt. Over time, you'll naturally observe workers getting better and better at their tasks. You have a few options. The first is simply allow more idle time in your system. Idle time is obviously waste. You know that in order to drive up efficiency without overproducing, you're going to have to remove a worker. I've found that the best way to do this is to target the last worker in the sequence. I let the team know that the goal over time is to absorb the tasks of the fourth worker while still meeting customer demand. I also make sure that the worker being removed is the best and most versatile worker in the group. This way, I'm able to move him to another area where he's able to pick up another skill set. I've also found that the best workers generally have the best attitude and are willing to move to other cells to learn. Don't make the mistake of targeting and removing the worst performing worker. This will hurt morale and send the wrong message. Now you need to consider how materials will be replenished in your cell. I like gravity-fed racks for many reasons. First, they're intuitive. The top rack carries full bins and the bottom rack carries empty bins. Notice they don't require any power. Gravity pulls down the next item to be produced, and gravity pushes away empty bins towards the material handler. Another reason why I like them is you can sequence what needs to be produced. If the rack were flat, an operator could accidentally pull the wrong item. But gravity forces the next item in the sequence toward the operator. So this is what it looks like from above. The material handler visits each station. He removes empty bins and replaces them with full bins in the exact sequence they are being consumed. After the material handler is done with his round, he goes back to the supply area to refill the empty bins he just picked up. Notice that we keep the supply area far away from the cells. This is by design. Operators going to refill bins is not part of their standard work. If they run out of parts, we don't want them to replenish their own bins. If supplies were located close by, they'd be tempted to do so. If they keep refilling their own bins, this masks issues with the material handling area. Remember, we want to expose opportunities for improvement, not mask them. So in closing, one of the first organizations we worked with took us on an initial tour of their facility. The operations manager was proud and wanted to let me know the team environment the company had. He told us how the shipping department often gets jammed up, so the office personnel, sales rep, and even the VP roll up their sleeves and ship product. This favor was returned about once a week by the shipping department when the front office was in a jam. It wasn't until after we were able to smooth the process did the operations manager realize the flaw in his previous teamwork statement about the organization. So take a moment and think, is your company organized to allow value to flow smoothly from beginning to end like this well-organized relay race? Or do you spend more time aimlessly huddling around soccer balls in the form of log jams and daily fires? So here's a quick summary of what we learned. We defined what cells were, we explored the different types of cells, we looked into creating cells, and we took a deeper dive into standard work in process.